Today's webinar is part of our Everyday Environment webinar series, which is offered on the second Thursday of each month. The webinar will be recorded and the recording will be shared to University of Illinois Extension's YouTube page. Please allow some time for processing and closed captioning. We'll follow up with an email when the video posts online. If you have a question, please feel free to put it in the chat box. I'll be moderating the chat and keeping track of questions, and we'll try to get through as many as we can at the end of the webinar. We also want to mention that this webinar is a certified green event through the Institute of Sustainability, Energy, and Environment at the University of Illinois. We recognize the importance of sustainability, and this webinar format has made it possible for us to offer these programs at a lower carbon footprint than our traditional programs. We encourage you to think about ways that you can be sustainable in your everyday life. I am now going to start the record button. Thank you again for joining us for Reduce Flooding and Water Pollution, How Rain Gardens and Native Plants Improve Water Quality. I do want to give a little bit of a bio background on each of our speakers. And I just lost that. I am so sorry, but in the sake of time, I'll let each of the speakers give yourselves a little brief intro, and we'll let Eliana take it over. Again, Eliana, my apologies.
No worry, Dwayne, and thank you so much for kicking us off today. I'm Eliana Brown. I'm an Extension Water Quality and Stormwater Specialist. I'm also with Illinois Indiana Sea Grant. Lane, how about you introduce yourself and then I can start us up.
Sure. My name is Lane Kanoki. I am an outreach associate for the University of Illinois in Illinois Indiana Sea Grant. Good afternoon, everyone.
Great. So, and thank you all for being with us today. Lane and I are going to talk about reducing flooding and water pollution with rain gardens and native plants. We do want to note that this topic ties into the Illinois Nutrient Loss Reduction Strategy, which guides state efforts to improve water quality in Illinois and downstream by reducing nitrogen and phosphorus levels in our lakes, streams, and rivers. So we're going to start today by giving you a little Stormwater 101. We'll follow that with an intro to rain gardens, and then we'll talk about our demonstration landscape, the Red Oak Rain Garden. Finally, we'll close out with resources and ways to learn more. Well, I am actually going to turn off my video to save a little bandwidth now at this point. Yep, thank you there. We are need to have this definition of what stormwater is. Rainwater or snowmelt runs across the land instead of soaking into the ground. It can pick up pollutants. I think this photo that you see here on the screen, that's a really great representation of what kinds of pollutants that we can have off of our roads that go into that little storm drain. You can barely see that storm drain that is just below that kind of dirty snow melt there. It's a beautiful April day. The snow feels like it's well in our rear view mirror, but you can remember back just a few months ago, you probably saw a lot of these scenes. And then when you see them again next winter, I hope that you will remember that, that's the kind of stuff that these are the kind of pollutants that can come from our stormwater. And so it's really important that we make efforts to clean up our stormwater and clean up our land as much as possible. So next slide, please. There are two kinds of surfaces that we need to know about when we're thinking about stormwater: impermeable and permeable. Impermeable are just those hard surfaces like our roofs, roads, concretes. It just doesn't let water soak into the ground. Permeable, on the other hand, does allow the water to soak into the ground, thinking vegetation and green infrastructure. And we're going to talk a little bit more about that in a few slides. Next slide, please. And we're going to jump up now from kind of our site-specific details to a watershed scale. You may have heard of this term watershed before. All of that it is it's the land that drains into a water body. So wherever your nearest lake or creek or river is, all of that land that drains into it. And now we'll jump up in scale to the state level. Next slide, please. This map shows land cover in the early 1800s, which was primarily forest, that's that green area, and prairie grassland, that's that kind of beige looking area. And in the next slide, you can see our present day, which is primarily agriculture, that's in yellow, and urban areas, that's in pink. So today we're focusing primarily on these urban towns and cities for this talk. But the main thing I want you to know about this is just that our land cover has changed drastically, and those changes in land cover really have an effect on our water. When you look back to what we had, these vast prairies with extensive root systems absorbing and filtering water, which you can see how long, how deep some of those root systems are on this slide, to what we have now in our towns and cities. I mean, there are really big implications to this. With development, we have lots of that impervious surfaces that we just defined, and we also have a lot of lawn. And lawn, on average, has root systems that are only 2 or 3 inches in depth, as opposed to these native plant root systems, which can go down 15 feet. So next slide. When you couple that with storm sewers, like one you see here, we have storm sewers all over our towns and cities. You put that with the fact that our storm sewers are really great, and we're grateful that they are so good at taking water swiftly away from our streets. But there are implications to that as well. Next slide. You end up with a situation that's described by this graph. So right now, or excuse me, pre-development, you see that's what this green line looks like. And we have this rain coming in, and the green line is what the stream would see in terms of flow. So the rain starts, it kind of very gently comes up in terms of going a little bit faster, and then it kind of gently comes back down. The difference with post-development is, boom, with this red line, when the rain hits, because our storm sewers are so good at bringing that water quickly, you get that really big hit at the beginning. And what can happen is that it deposits pollutants and it scours the stream banks, and it can look like this. Problem with this is that these scoured stream banks just aren't as good at supporting aquatic life, and they have from that degraded water quality. And that is what you see here, as expressed here from this map that's showing the impaired streams and lakes. This is a map that was created by the Illinois EPA in their integrated water quality report. And these red areas are streams and lakes that have been degraded from stormwater runoff. And then, of course, there's this issue of flooding. If you're here, maybe you have had floods, maybe your town has had floods. Here's a couple of photos of some recent big Illinois storms. And this translates into cost. The Illinois Department of Natural Resources report on the Flooding Awareness Act found that documented damages from flooding in Illinois from 2007 to 2014 totaled more than $2.3 billion, and that's billion with a B. Next slide, please. So for the next 3 slides, these were ones that our state climatologist Trent Ford have provided for us. The slide here shows that our rainfall trends are increasing. So if you have been hearing more about flooding and big storms, you are right on the money, because that is exactly what the data is showing. Next slide, please. And we're also seeing this increase in extreme rainfall. Now, extreme events are defined as those where 2 inches or more of total precipitation occurs in a 24-hour period. Next slide. Looking into the future, this figure shows the projected change across the Midwest. The changes are shown from this 2070 to 2099 average relative to a 1990-2019 average. And in most of our seasons, we're seeing increased precipitation, not so much in the summer, but in the other seasons. Next slide. So what can we do to shore up resiliency and improve water quality? There are things we can do. That's the good news. I'm giving you the not so great news, but there really are things that we can do. We can support green infrastructure projects like the ones that we see here on this slide. The two on the top left, if you can stay on that slide, those are constructed wetlands. The two bottom ones, the one on the left is a green roof, it's permeable pavement, and the one top right is rain garden. Today we are focusing on rain gardens, so go ahead and go to the next slide, please. But I want to talk about, just real briefly, what all of these strive to do, and that is to mimic the natural landscape's ecological functions. So what we're really trying to do is slow down the water, let it soak into the ground so that we can come back to that green line, that pre-development, soaking more into the ground so that our downstream rivers and lakes can behave a lot more like they did in the early 1800s. So next slide, please. As I've mentioned, we are going to focus on rain gardens, and with that, that's my cue to hand it over to Wayne.
Thanks, Eliana. So I'm going to take the next couple of slides to give everyone a fairly basic overview of what rain gardens are, some of the reasons why they are good for the topics that we've discussed so far. So rain gardens are typically bowl-shaped landscape features that capture and absorb rainfall and snowmelt. A carefully selected palette of plants and layers of mulch, soils, and aggregates are used to mimic the ecological functions of natural landscapes. These gardens can help to alleviate local flooding while improving downstream water quality and recharging groundwater. They also provide a lot of other co-benefits, such as the creation of habitat for wildlife, even carbon sequestration. This is a typical rain garden section. So we see that bowl-shaped feature. As rainwater and snowmelt flow into the rain garden from the surrounding surfaces, whether those are permeable surfaces or impermeable, the rain garden collects that water temporarily into the basin, this low area of the garden, and it allows that water to soak into the ground. The water is typically designed to be fully absorbed into the ground within 24 hours to prevent mosquito development and to minimize damage to plants. Rain gardens have 3 zones to be aware of. We have the banks, the slopes, and the basin. The banks are located at the top of the garden, sort of the high and dry areas. Those are spots that should not experience durations of ponding. Slopes are a step below that, and they are the transition zone between the banks and the basin, where short periods of ponding should be anticipated, and moisture levels in that zone could be considered average. The basin is the lowest area of the garden where longer periods of ponding and wetter soils should be expected. Each of these zones and the conditions in them have implications as to what kind of plants can be located in them. Plants in the banks need to be able to withstand longer periods of drought. Plants on the slopes need to be adapted to more of those average conditions. And plants in the basin need to be adapted to our wetter soils. Luckily, Illinois has an amazing wide variety of native plants that are really great for each of these conditions. So to talk about a very specific rain garden, I will hand it back over to Eliana to talk about the Red Oak Rain Garden.
Thank you, Wayne. So The Red Oak Rain Garden is a large public demonstration site on the University of Illinois campus. Now, it is larger than what most people would build, say, in a residential application, but we like to talk about it and showcase it because it provides our base of education and outreach regarding these topics. There are a lot of things that we have learned from working on this project. We have a number of lessons learned that we want to share with all of you. Now, this is where it's located on the University of Illinois campus. One thing I'll point out, and Lane, maybe you can help me here with your cursor, is to show the sidewalk that's coming across Lincoln Avenue that comes in to where Red Oak Rain Garden is, which is basically to say that there is a lot of pedestrian traffic that's going to and fro this area, which makes it a very good place for a demonstration garden because a lot of people walk by and see it. There are actually two iterations of the garden. It was first built in 2006 on this land that you are seeing right here. This land flooded near the oak tree that you see in the picture on the left and over the sidewalk, the picture that you see on the right. So when people were walking into campus, they would see a really big puddle. And so in 2006, the effort was led by Professor Tony Endres, whose classes designed and built the garden. In the middle photo here, you see a couple of his students installing rock. Next slide is to kind of highlight there was a lot of rock, like in 60 ton of it. And the reason for that is that at the time, the thinking on design for rain gardens utilized examples from the Pacific Northwest, which used a rock-centric design. So this picture on the left here, you can see in the background, I mean, there are plants, you can see a small amount of plants, but a whole lot of rock. An issue with this as we go forward in time is that we are in East Central Illinois, we're not in the Pacific Northwest, and rock is very difficult to maintain, especially under 2 trees without herbicide. And so in 2019, I led a team, which includes the talented Lane, to renovate the garden. It started with rock removal and excavation. Next slide, please. Soil is the foundation of rain gardens. We backfilled the sunny portion of the garden, the portion that doesn't have trees, with engineered soil, which increased the ability for the garden to soak up water. Really made it an even more permeable place. Now, in addition to that, we applied mycorrhizal inoculant over the entire garden, which gives us added boost. We didn't do very much excavation in the part of the garden that has trees, and the reason for that is because we didn't want to harm the trees and wanted to preserve their roots, or we might have done this throughout the entire garden. But we did add that mycorrhizal inoculant over the entire garden. Now, on top of that soil went thousands of plants. A lot of plants, and we needed a lot of help to plant those plants. So we had some incredible volunteers. We built up our volunteer base from the get-go, from the Extension Master Gardener and Master Naturalist programs. In addition to those community volunteers, we also had students. We had classes from horticulture, landscape architecture, civil engineering, and more engaged in service learning to build the garden. And this is what it looked like for, we built it in the fall of 2019, and this was the summer of 2020, already very lush. We used plugs to install the garden with, which we think worked very well. There's some research showing that that's going to do a really great job for best success. We also believe that mycorrhizal inoculant gave the plants a nice boost and helped it to thrive even in that first year. Want to point out on this photo, you see a little bit of rock. Wayne, maybe you can point that out. Thank you. Yeah, that is where the water is coming in. So that's the inlet. So we have rock there to kind of break up the energy of that flow of water as it comes in. But then the rest of the garden is very much a plant-centric design. And with that, that's my cue to hand it back over to Lane to talk about that.
Thank you again, Eliana. So as Eliana discussed, the first iteration of the Red Oak Rain Garden had a very rock-centric design. The renovation of the garden introduced this plant-centric design that allows us to soak up more water, improve our soil health, and add plant diversity, habitat, and beauty to the University of Illinois landscape. Inspiration for this new design came from Thomas Rayner and Claudia West and their book, Planting in a Post-Wild World, which details methods of looking at landscape design in terms of layers. At the Red Oak Rain Garden, we have a ground cover layer, a structural layer, and a seasonal layer. With these, we are able to increase aesthetics, we're able to build ecological communities, and we're able to decrease long-term maintenance. Along with the engineered aspects of design, these are all key elements of ensuring that rain gardens and green stormwater infrastructure designs are successful. We need them to continue to improve water quality and to remain beautiful for many, many years. So we'll go into some detail about each of these layers, starting with the ground cover layer. Plants here are meant to form a kind of green mulch, whether for aesthetics or weed suppression or both. The Red Oak Rain Garden is one of those examples of both. There should be a lot of plants here, and they can be installed in mass, meaning you can install, up to 100 or even more of individuals of a single species. You want to get those established quickly to cover as much ground as quickly as possible. These are usually going to be short in stature, and they spread out as they grow. As they fill in and mature, they protect soil, they protect from soil erosion, they provide habitat, and even overwintering pollinators find refuge there. This is a photo of what our ground cover layer looked like the spring after the 2019 renovation. So in this image, you can notice the sedges that are planted. We have these about 15 inches on center. And then here we are in spring of 2022, and you can notice that our sedges have really filled in just as they were designed to do. This is Pennsylvania sedge here in the image on the left. You can really get great textures and great colors from the ground cover species. On the right, we have wild ginger, we have prairie alum root, both of which are great Illinois native species. And this is a selection of ground cover species that are found in the Red Oak Rain Garden. This is not a comprehensive list of all Illinois native species that could be considered ground covers. This is just what we have in our 10,000 square foot demonstration site. So you notice that we have several species of sedge in here. We've got some ferns. We also have some flowering species in this layer. The next layer is the structural layer, and this is where you find the larger plants typically. So this is basically the opposite of the ground cover layer. Here you'll find plants that grow tall or have interesting architectural forms. We could be looking at shrubs, tall forbs and grasses, even the trees could be considered plants in this layer. Typically, here you're going to need fewer individual plants to make a big impact. So smaller groupings of structural plants are typically appropriate. In the Red Oak Rain Garden, we have forb species like rosinweed. We also have shrubs like red chokeberry that you see pictured on the right here that fit into our structural layer. Again, here is our list of structural plants found in the Red Oak Rain Garden. We have several shrubs and some larger or longer lasting forms that fit into this. The third layer of planting design at the Red Oak Rain Garden is our seasonal layer. And this is where we find a lot of the more familiar wildflower types that folks are generally more familiar with. The plants here are visually dominant for a period of time, usually as they're going through their bloom season. Larger groups and even mass plantings of individual species in this layer can make a very large impact. Here are a few visual examples of seasonal plants in the rain garden. We have orange coneflower on the left, which provides a big pop of color in late summer and early fall, which is really great for students as they arrive back on campus around that time of the year. Butterfly weed gives us some nice orange in the summertime, while wild geranium blankets a shaded area of the garden with these lavender colored blooms a couple of weeks away from their peak bloom this spring. We have a lot of plant species in our seasonal layer at the rain garden. We have everything from coneflowers to asters. You'll notice that we do have a few cultivars of native plants in here, and even one or two non-invasive, non-native species as well. The last layer that I want to mention today is our ephemeral layer. And these could be grouped in with the seasonal layer, but I personally prefer to keep this one separate for one reason. And that is that they are species that emerge in spring, they do their thing, and then they go dormant in the summer months. They need to be intermixed with ground covers that fill in the void that they leave when they go dormant. We're kind of entering the peak season for our ephemeral blooms. We have a terrific display of orange tulips that bloom alongside hundreds of our native Virginia bluebells. It's a great color combination to have on the University of Illinois campus. We are just approaching the peak bloom of those, I'd say within the next week or so. We've had a very warm couple of days here. And so if you're in the Champaign-Urbana area, would highly recommend checking that out. It's a really nice display of color there at the garden. We also have species that will come in a little bit later this spring in our ephemeral layer, like shooting star and wild hyacinth. Here's our list of the species in the ephemeral layer. There are some really great Illinois native ephemerals that can perform beautifully in green stormwater infrastructure, and we hope to add more into the garden in the future. As part of our adaptive management plan, we want to make sure that our volunteers become comfortable with stewardship of the species that we already have planted and then expand as possible. And along those lines, I'm actually going to send it back over to Eliana to cover our next few slides.
Thank you, Lane. Long-term maintenance and stewardship is always a consideration for a project like this, and even for smaller projects. If you have a garden, you have to think about stewardship. We are really fortunate to have a combination of community volunteers and student volunteers. Via service learning events, all of these volunteers learn about native plants and rain gardens so that they can teach others about them. To help with this, we worked with a student named Piper Siblick to create an interactive digital map. Now, this is the, I guess, world debut of our interactive map. And Lane and I are going to give you a live demonstration of how this works and how it can be really beneficial for stewardship on a project. So if you've worked with native plants, you may know that as they are emerging from the ground, they don't always look like what they look like when they are fully larger. So it might be difficult to know whether to weed something out or not. The example that we've pulled up here is if you know that you are in this portion of the garden, you're in cell 2, you're in the north portion, and say you see a plant that has a broader leaf, maybe a dandelion. Now, I'm guessing most people on this webinar know what a dandelion looks like, and you know that it has kind of a broader leaf than what Pennsylvania sedge has. So if you see that, you didn't know that it was a dandelion, you see that it has a broadleaf, you see that it doesn't look like this, then you would know this plant doesn't belong here. I'm going to weed that out. And this really helps to take the guesswork out of knowing whether a plant is a plant that's intended to be in the space or not. The other thing that is really nice with this interactive map and the way that we've worked it is that it includes all of this incredible plant information, so that somebody that maybe comes upon the garden sees Pennsylvania sedge, sees how beautiful it looks, and wants to integrate it into their own landscape. They can learn about attributes of the plant and how it's going to grow, how to maintain it, and where it might grow best. Third aspect that I want to talk about with this interactive map that we find really great is that, as Elaine described, there are layers to this design, and we have some intermixing of plants, some interplanting. So with this little toggle on the bottom right that Elaine is demonstrating, you can see, and it follows also with the areas that are highlighted on the map, you have this understanding of, say, okay, so a couple of these shapes are overlapping each other. What are the plants that are intended to be intermixed there? And what's kind of nice about that is that it gives you an idea of what plant combinations do well with one another in these particular situations. So anyway, that's our interactive map. We did work with our volunteers, as Lane was talking about, adaptive management, to ensure that our volunteers have a good understanding of the decisions and the way that we're managing the garden. We worked with them because they're the folks that we primarily have an audience for this map, and wanted to make sure that that it worked for them. They gave us incredible feedback, which improved the map. So if you are doing any kind of public projects with volunteers, we highly encourage to have your volunteers be part of the decision-making process. Next slide, coming back to the presentation, just want to show you some of the really beautiful photos of the garden through these last few years since it has been renovated. The renovation did include a sustainably sourced lumber bridge that spans the garden. Of course, most rain gardens are not going to have a bridge, but ours really needed to have one. There was a path of desire where students wanted to be walking through that area. We were very lucky to work with the university's Allerton Park, who gifted us this black locust lumber, which was part of their normal culling to make way for more native trees on their landscape. And then we worked with a local miller to cut the lumber and have it constructed on our campus. We really love it. I think the students really love it as well. It looks great in most every season, and we have been really delighted to see last year at graduation, and we expect to see it this year at graduation in May, that a lot of students are lining up to get their picture taken on this bridge with their cap and mortar to kind of mark their time at the University of Illinois. I believe the next slide shows our expansion garden, which has which was planted in 2021, and this mural was created in 2022, so just last year. It also shows our tulips. So I wanted to note that almost all of the plants in the Red Oak Rain Garden are native plants, but to be a non-native plant in the Red Oak Rain Garden, you have to be a really special plant. And these tulips are definitely a special plant, and they can live in harmony with the native plants. As Lane was talking about, they're interplanted with the Virginia bluebells, and University of Illinois colors are orange and blue, so that works really well for us. We were inspired by Chicago's Lurie Garden, who does this with great success, and I think that it's a nice addition to the garden, and can be a nice addition to somebody's home landscape within their own native plants. So next slide shows our garden in action just after a rainstorm. It doesn't stay wet for very long, even though we don't have the engineered soil in this portion of the garden. The permeability, the infiltration is really very good, and it soaks in pretty quickly. But we were able to capture this photo after a rainstorm with a little bit of sunshine coming through. You can just imagine that there's a rainbow in the background, but that's out of frame. So handing it back over to Lane now to talk about engagement.
So as part of Illinois Extension, the Red Oak Rain Garden team believes in providing excellence and educational programming and providing accessible programs that help people solve problems. And the Red Oak Rain Garden does both. Our team creates service learning opportunities for students and community members, and inspires visitors to find out how they can create healthier landscapes where they live. This is a collage of some photos that were taken at events throughout 2022. Our volunteer events, we've got tours that were well attended. We've had in-service trainings that have taken place at the Rain Garden. Even just last fall, we had over 70 students attend a single presentation during Student Orientation Week. And so we're really happy to see the level of engagement that we've had so far with the Rain Garden. If you're interested in learning more about the Red Oak Rain Garden, or if you want to see some of the things that we're up to, check out our website, redoakraingarden.org, or follow us on social media at Rain Garden UIUC. You can also sign up for our e-newsletter by scanning the QR code that you see on the screen. I believe that these links are also going to be put into the chat box if you're interested. There are a lot of really great resources out there to help you with these topics. The next few slides that I'm going to cover talk about some of the resources that Extension has had a hand in. The first that we want to mention is the Southern Lake Michigan Rain Garden Manual. This is a guide that covers just about anything you may need to know for planning, building, and maintaining your rain gardens. And again, I think that these links are going to be put into the chat box for you. This is a recently produced guide from Purdue called Introduction to Rain Garden Design that you can download. One of our goals is to inspire folks to take home concepts of the Red Oak Rain Garden. And along those lines, we've developed a series of brochures, including the 3 that you see here. And these 3 that you see here and more. There are some that are still in development, so stay tuned for those as they become available. But those are all available at go.illinois.edu/RORG resources. Eliana has also produced a series of short videos that cover the topics of green stormwater infrastructure. They include rain gardens, permeable pavers, and green roofs.
75 minutes running 62.
Extension has recently launched a new webpage that discusses rainfall management. That one is go.illinois.edu/rainfall management. And we also just launched a new website called Illinois Groundwork, which provides green infrastructure research, tools, and resources to stormwater professionals, local leaders, and community members. One of the tools that we built into this website is an interactive plant finder, which can help you select plants for your rain garden. This can be found at illinoisgroundwork.org. And with that, I will hand it back over to Eliana one last time to talk about the Rainscaping Education Program.
So if you want to receive training about rain gardens and other rainscaping topics, Extension has this Rainscaping Education Program that we imported from Purdue. Next slide, please. It provides 15 hours of education, which includes home learning, and it also has this hands-on rain garden building instruction that is pretty great, so you can see firsthand how to build a rain garden yourself. Last year in Illinois, 62 people were trained and 11 gardens were built as a part of this program. If you're interested in participating in a rainscaping course, reach out to your local extension office to see if one is being offered near you. And this next slide has the link for how to get more information about the Rainscaping Education Program. So with that, we want to thank you all very much for attending our talk, and I think it's time to open up for questions. Dwayne, I'll hand it over to you, so in your capable hands, you can tell us what we're going to do next.
Okay, so the questions, we should have good time for these. The first one that's available is, how do you decide which plants go where when so many natives grow from 3 to 9 feet?
Lane, that's you.
I was going to say that's probably a question for me.
Yes.
So that's a really good question. There are a lot of plants that have a wide range of heights, especially when we're talking about Illinois native species and not, say, a cultivar of a native species that is maybe more typically 3 to 4 feet tall, right? So when it comes to rain garden design, or really garden design in general, the way that I like to handle that is I'm very selective about choosing species that do have sort of a smaller range of height variability. And if I want to use a species that is going to have that 3 foot to 9 foot potential, I might use that towards the back of a garden, or and if we're talking about in a rain garden, that might go in the basin if that plant is also adapted to wetter soils. I would also say that if height is something that you really want to pay attention to, and you don't want something that's going to get 9 feet tall, try to avoid species that have that potential. There are hundreds and hundreds of Illinois native species that work well in garden design. And you should be able to find a good variety of species that do stay a little bit on the smaller side. Hopefully that answers your question.
Okay, the next one, did you use a standard ESRI GIS application to make the map?
Eliana, do you want me to take that one?
Yes, go right ahead.
So I will do my best to answer that question with the limited Esri knowledge that I have. It is not a basic level of Esri level. We did have a student that was majoring in that field, and through the university we had access to basically the full Esri suite to build that map. It's not something that I believe can just be done on, say, the online version. There was quite a bit of work that went into that map, months and months worth of work actually, and I believe most of that had to be done in the more professional Esri levels. I don't know exactly what the program name is. I'm just going to call it the professional Esri accounts. Sorry, I can't be more specific on that.
Okay, let me get back to where we were at in line here. How important is it to use a bioengineered soil in a rain garden?
It's a great question. I'll go ahead and take that one. So, it really depends on what your native soil is. If you have a soil that is composed of a lot of sand and it has really good permeability, you might not need to have that. Kind of also depends on, the answer is it depends, right? Like a lot of these things. But so having an understanding of how much water is going to the area that you'd like to build the rain garden. And then this is the part that's really important, is doing an infiltration test. So you know how many inches over a 24-hour period can be absorbed. You might not need to use an engineered soil. For us, we really wanted to make sure that we were going to have the best chance and over that large area of absorbing as much water as possible. Plus, we wanted to try it out to see.
I will say, I might just add one point to that. And it's something that we have learned as we've gone along. The plants that went into the area of the garden that we did use the engineered soil mix established very quickly. The roots were able to expand into that engineered soil very quickly. And sometimes it's not always the best thing with native plants, as if the soil is too perfect, the plants might flop. But as our plants have grown together, which again, they're designed to do, they then have the structure to kind of help support them in that plant-centric design. The plants that we installed in the areas of the garden where we did not put in that engineered soil mix took longer to establish themselves. But by the third year, which was last year, they had accomplished their goal of covering the ground. So just wanted to make that one additional point to the engineered soil mix question.
It's a good point. Kind of depends on what your goals are for your project.
Mm-hmm.
It additionally, it depends.
Yes, it does depend.
We do have several more questions, but Lane, I was going to ask if you could advance the slides to get to the evaluation code.
Absolutely.
And for folks that would like to do an evaluation, we encourage you to do that. There is a Q code there that you can use to get to that evaluation. But for the next question, wouldn't permeable pavement have limited application due to freeze-thaw cycles?
That's a great question. So and that's been a question, I think, especially in our northern regions, that has been asked ever since people started utilizing permeable pavement. The University of New Hampshire has done a lot of research on this. And, you know, they're a little different than Illinois in that they stay colder. They have had really good success with permeable pavement. We here in Illinois have also had good success with permeable pavement. I think it myself personally, in looking at projects in Illinois, you know, because there's a number of different kinds of permeable pavement, permeable concrete, permeable asphalt, and then there's the permeable pavers. I have a preference for permeable pavers because if there's an area of it that is having some issue from freeze thaw for whatever reasons, there are portions that can come out and you don't have to redo the whole thing. Freeze thaw, it still can work, and we have seen a number of projects in Illinois that are working well with permeable pavement despite our freeze-thaw cycles.
Next question. We have an area of lawn just beyond the farthest edge of our septic field, which stays wet after a significant rainfall. Would there be any reason not to plant a rain garden in that location, considering the septic field proximity?
So would they want to plant over the septic field? Is that what I'm hearing?
I think it's near the edge of it.
Near the edge of it. I'm not sure that we want to make a comment on that without looking into it. I think that that's a really good question, but Lane, I'm not sure if you have thoughts. I'm a little wary to say anything about septic fields without doing a little research and getting.
I do have a comment on that.
Mhm.
I think with those deep root systems, I think you have to be really concerned about not getting that very close to the drain field, because they will go into those drainage lines pretty easily as they get more mature.
Yeah, we we have a silver maple that is growing next to ours, and the last thing that you want to deal with are roots in those lines. Unfortunately, we do. Tree roots might be different than native plant roots, but not fun nonetheless.
Next question, what's the best way to amend clay soil to support a rain garden? Or does much need to be done?
Well, so again, that infiltration test will tell you, but you've said clay soils, which tends to indicate that you're going to have a much slower infiltration rate. And so an engineered soil might be called for in that situation, where you'd be removing the amount of soil that you would need to remove for the rain garden, but then you need to remove a little bit more than that, and then replace it with primarily a mixture of primarily sand, compost, with the native soil being clay. You would want a smaller percentage of native soil going back into there. But there are recommendations in the resources that we've given you, especially the first two, that Southern Lake Michigan resource and the Purdue resource, which cover all of that.
Next questions. How small can a rain garden be? For example, to cover an area about 4 feet square, that is the side of the outflow of all water of our house roof.
Well, okay. So I like that question. How small can a rain garden be? There are these things called stormwater planters. It could be in a planter, so that can be a very small thing. The thing that I would be concerned about, you said near your house, and we didn't go into siting rain gardens. That's all covered in the Rainscaping Education Program. But you want to make sure that there is at least 10 feet between the footprint of the house and the rain garden. Can even be more depending on your basement kind of situation that you have in your particular area. But your question was about size of the rain garden. So covering size, the thing to determine this is whether the amount that would be coming off of your roof. There are calculations that are in those first couple of resources, and those will let you know what size of rain garden that you would need to have in order to capture. And this is the first flush, which is generally 1 inch of rainfall coming off of that roof. So I go to those resources. I think basically these are really great questions. I like hearing these kinds of questions.
All right. And I'm sorry, Lane, if you could go back now one to show the next session. Well, we've got time. Our
Of course.
speakers do have to take off write it too. So we'll take what questions we can. But the next one is, should we be worried about rain gardens becoming polluted, especially if runoff comes from adjacent properties or the street, for instance?
That's a great question
Mhm.
too. And there have been a few studies that have looked at that. It's a very, very good question. So the thing that is good to know about this is that there's a whole host of microbiota that are living in the soil that can help break down the pollutants that come into a rain garden. And so most studies, I believe, are showing that that the microbiota are very much our friend, and that they do not turn the rain gardens into a polluted area. So it's a very good news, I would say, and much better for it to be treated on site than to go to our waterways, where it's not going to have that same kind of benefit.
Next question is, how is an infiltration test done?
Great question. I don't have time to drop in this link. If you go to that Rainscaping, go to that Rainscaping link in the Purdue Rainscaping page, there is a really great video that comes from the Purdue Rainscaping program that stars Dr. Jane Frankenberger from Purdue Engineering, that goes through step by step on how to do an infiltration test. But basically, you dig an area, you fill it with water, I believe a couple of times to get it oversaturated, and then you note the amount of time that it takes for that area to drain. But find that video, because it will walk you through how to do it.
This will probably have to be our last question. Could you please describe any advocacy or outreach efforts happening with municipalities to rethink ordinances that prohibit or have requirements that make installation of rain gardens and green infrastructure infeasible in residential areas?
Great question. A lot of municipalities are looking at that themselves, because they know that a lot of existing or some existing code do prohibit or rain gardens or native plants. And there's some of that code that still needs to stand. If it's in the right of way, you don't want to have very tall plants, for example, because that can be a safety issue. But where that's not, where those kinds of plants are not an issue and they can do very well, the municipalities, many of them are looking at their code to make sure that green infrastructure and rain gardens are allowed. So I'm not aware of advocacy that's being done by any groups, other than I know that many municipalities are looking at that kind of thing themselves to do.
Okay, Ileana, Lane, thank you so much. Great information there. You do see again, there were a few questions and we apologize for not being able to get to all of them, but you have their contact email information there. So I'm sure that if you wanted to reach out to either or both of them with your question, I'm sure they would try to help you with that information. So again, thank you all for attending. Lane, Ileana, great job as usual. So we thank you all for attending, and hopefully we will see you again next month.
Thank you for tuning in to CUWise TV. We hope you enjoyed the show. This video can be accessed anytime on youtube.com. In the YouTube search bar, type in UPTV6 and look for their microphone logo. We hope you will join us again next week for more local, engaging content designed specifically for Champaign County older adults. Take care and stay safe.